Experiment 2.b. Aim: to determine the equivalent resistance of two resistors when connected in parallel. Materials required: a plug key, connecting wires, an ammeter, battery, voltmeter, rheostat, a piece of sandpaper, and two resistors of different value. Theory: when the resistors are connected in parallel with a combination of cells battery, then in such a case the total current I is equal to the sum of the separate value of current through each branch of the combination. That is, I is equal to I1 plus I2 plus I3 plus so on. In the above-mentioned circuit, let Rp be the equivalent resistance of the parallel combination of resistors. By using Ohm's law we have I is equal to V upon Rp. On using Ohm's law to each resistor, we get I is equal to V upon R1 and I2 is equal to V upon R2. But I is equal to I1 plus I2. V upon Rp is equal to V upon R1 plus V upon R2 from equations 1, 2 and 3. 1 upon Rp is equal to 1 R1 plus 1 upon 1 R2. When resistors are connected in parallel combination, the total resistance is the reciprocal sum of the individual resistance. That is, 1 upon Rp is equal to 1 upon R1 plus 1 upon R2. As current remains constant in series circuit, we cannot connect bulb and room heater in series because their current requirement is different. Hence such devices are connected in parallel so that the current is divided through the different electrical gadgets. Procedure 1. Determine the individual resistances R1 and R2 of the given resistors as per Experiment 1 and circuit diagram of Experiment 1. 2. Study the circuit diagram for parallel combination of R1 and R2 as given in circuit diagram. Make the connections of various pieces of apparatus as shown in arrangement diagram. 3. Insert the key and adjust the rheostat for a small current as indicated by ammeter A. Note the ammeter and voltmeter readings. 4. Increase the current by adjusting the position of the slider of the rheostat suitably. Record the corresponding readings of ammeter and voltmeter. Take 3 sets of observations and determine the mean value of the equivalent resistance R of the parallel combination. 5. Record your observations in the observation table. Observation and calculations. 0 error of voltmeter is equal to volt. Least count of the voltmeter is equal to volt. 0 error of ammeter is equal to ampere. Least count of the ammeter is equal to ampere. Observation table. On the basis of above procedure, complete the following observation table given below. Result and conclusion. Resultant resistance of the resistors in parallel. 1. By experiment, R is equal to ohm. 2. By calculations 1 upon R is equal to 1 upon R1 plus 1 upon R2 is equal to ohm to the power minus 1 or R is equal to ohm. Within the limits of experimental error, the experimental value of R is equals the calculated value of R. Thus, the relation 1 upon R is equal to 1 upon R1 plus 1 upon R2 for parallel combination is verified. Precautionary measures. 1. The connecting wires should be thick and the insulation at their ends should be removed with the help of the sandpaper. 2. Connections should be tight, otherwise any external resistance may introduce in the circuit. 3. Connections should be set as per the circuit. 4. The ammeter should always be connected in series with the resistor in such a way that the current enters at the positive terminal and leaves at the negative terminal of the ammeter. 5. Voltmeter should always be connected in parallel to the resistor. 6. Calculate the least count of the voltmeter and ammeter accurately. 7. Check the pointers of the ammeter and voltmeter should remain at 0 mark when no current flows through the circuit. 8. Current should be passed through the circuit for a short time while taking observations, otherwise current would cause unnecessary heating in the circuit. Heating may change the resistance of the resistors.